So in this session we're going to talk about VTP configuration revision number. So let's see what is VTP configuration revision number, and this is the continuation of VTP, and the previous video was about the introduction. So let's continue with VTP. Configuration revision number. Configuration revision number is a sequence number for the database. So it's more like a serial number for the VTP updates. So suppose a VTP update has been generated, which contains the Vlan tag, the data, and it's the first update. So its configuration revision number is 1. Then another one has been created, 20, Vlan ID 20, the data, and its configuration number is 22. So this one logically the highest number wins. It says that highest number wins. So basically whatever number is higher than the previous number, this number should always be recorded. So this means that this update should always contain VLANs 10 and 20. So suppose 100 VLANs have been created, okay, and like from 2 to 101, and the next VLAN that needs to be created is 102 data, and say the configuration revision number is 101. Okay, so if I need suppose the network this network contained 3 switches, okay, 1, 2 and 3, and suddenly another switch was introduced, and so it will automatically forward the VTP update packet. So it will this new switch will install all the pre-configured VLANs that was in this packet, okay, in this very packet. Say this is packet number X. In the in the packet number X, whatever VLANs were configured before, means 101 VLANs, I mean from 2 to 101 VLANs will be installed over this switch number 4, plus the new VLAN that was created just now, okay, that was VLAN number 102. The previous 101 VLANs will automatically get installed over here, plus the new VLAN that was created. So this is what highest number wins means, okay. Now suppose the configuration revision number is it's mismatching, or some say there are 3 switches and configuration revision number is say 4, 5 and say 6. So this will not work, because the domain here remains unsynchronized, because the revision number is not matching. So the domain has to be synchronized. In order to keep the domain synchronized, the configuration revision number should always match. So these are the criteria that should be fulfilled to proceed with VTP. So these should be kept in mind thoroughly, okay. Now moving on to the lab, okay. So this is the topology I have got. This is the topology, okay, and I'll configure this switch as the server switch, transparent switch as this one, and client switch as this one. And after the lab, I'll be discussing about a certain phenomenon in this scenario, and we'll get to know why by doing the practical, okay. So let's move forward. I have the topology over here. Okay, now I'm just going to use one user, so that would be easier because we just need to ping and ping from the user and verify from the switch. So let's start. always always configure the access and trunk ports whenever you are beginning a lab. Okay, configure so fast ethernet 0/2 is an access port. Interface fast 0/2. Yes. Switch port mode access. Okay, fast ethernet 1 is a trunk port. It's a configure mode. Okay, interface fa0/1. So I am going to configure it as dynamic desirable, and I'm doing manual trunking, so DTP should be off. Switch port mode dynamic desirable, so active negotiation of trunking. Okay, access and trunk port, they have been configured. Now we're going to the second switch. Okay, second switch. Okay, enable, configure. Second switch has 0 1 and 0 2 as trunk. 0 1 and 0 2 as trunk. This is also a trunk port, and this is also a trunk port, and this is access port. Okay, trunk access. This is connecting to this switch, and this is connecting to this switch. So I'll be using a different command over here because both of these ports are having the same function. So interface range, see, range fast ethernet 0/1 hyphen 2 switch port mode dynamic desirable. Okay, yes, STP is working right now. So 0/3 will be access port. Interface FA 0/3 switch port mode access. Yes, switch second switch has been configured, and the remaining last switch we need to do the same thing. 0/1 will be the trunk port, as it is connecting this switch to this switch, and the end device is connected to an access port. Enable, configure, interface FA0/1 switch port mode dynamic desirable. Okay, and switch port mode access should be FA0/2 and FA0/2 switch port mode access. So right now we need to verify it. So for verification of the trunk port, int show int trunk. For the third switch, FA0/1 is in trunk port. Yes. Now show interface FA0/2 switch port. For the access, static access means I have configured the access port manually, and trunking is off because it's access, logically it should be off. And let's go to the second switch, the middle switch. Show interface trunk. So 0/1 and 2 should be trunk. Yes, it is. 0/1 and 2 desirable mode, trunking on. Yes. Show interface FS0/3 switch port. Static access, trunking is off. Okay. And now the first switch, show interface trunk 0/1. Yes. Show interface 0/2 switch port. Yes, same. Okay. So trunking and access port have been configured. Now we'll create VLANs. So VLAN 10 and 10. I'll use only one VLAN over here. Okay. So just to simplify, and let's go ahead. VLAN 10. Name is IT. Okay. So this is done, and so FA0/2 should be int FA0/2 switch port access VLAN 10. Now if we verify it, show VLAN brief. See, VLAN 10, the name we had given was IT, and 0/2 is the port that it is assigned for. Notice a thing here, for the first switch, if a 0/1 is not appearing in the port section. Okay. Now this is one of the vital things, one of the most. If a 0/1 is absent from this section, this is because this is a section for VLANs. Okay, for particular VLANs. Now as we have discussed in our trunking lecture, that trunk ports are a part of several VLANs. We cannot configure only one VLAN to a trunk port. Trunk ports are part of several VLANs. These VLANs have been configured and have been pointed to a single port. Okay, VLAN 10 to FA0/2, VLAN 10 to FA0/2. But by default, VLAN 1, this is the native VLAN. If no VLAN has been configured, by default every port on the switch is configured by default. Okay, by default it's in VLAN 1. So just remember that if it's a trunk port, and we are using the command show VLAN brief to see which port has been assigned to which VLAN, we will not see any of the trunk ports here. So let's move ahead and see what's in store for us in the second switch. Okay, switch 7, show VLAN brief. So logically we will be having two interfaces less in this section, in this switch. Let's see. fs0/1 and fs0/2, they are missing. Okay, they are missing because these two are the trunk ports. So yes, likewise we will also see this switch showing us the same thing. Show VLAN brief. See, fs0/1 is not there, 0/1 is not there. S is done. Okay, now we will remember, we will let's refresh our memories. In the default mode of Cisco Catalyst switch is VTP server mode. So by default this switch is in server mode, and these two are also in server mode. So I mean, by default every switch is in server mode. So what I'm going to do is I'm going to configure this as transparent and this as client mode. So let's move ahead. Switch 7. Okay, now first we have to finish our configuration here. VTP mode server, VTP domain, say CCNA. Okay, VTP password as Cisco in caps. So if you verify it, show VTP status. Right now we see that the configuration division number is 0. So let's create another VLAN, but will not define it for a particular port. Let's say VLAN 20. Okay, name R, whatever it is. Okay, so you say show VTP status. Yes, configuration division number 2, one for the creation of VLAN and the other for the name. Okay, this is how it works. And likewise, so I'll be configuring this switch as a transparent switch. VTP mode. Okay, VTP mode transparent, VTP domain CCNA, VTP password as Cisco. So let's configure over here also. Show VTP status. Configuration division number is 0. Now let's go back and create another VLAN, because I'll have to show you. Okay, VLAN 30. Just keep it like that. We don't need to name it. Naming is not compulsory. Okay, show VTP status. Previously it was 2, as we see here 2, as because I created only the VLAN, not the name, so it was +1. This is 3 here. And now we by remembering the concept of VTP server mode, it will advertise the VLANs. So what do you mean by advertising? Advertising means whenever it's sending the update to this switch, it will send the VLANs of 10, 20 and 30, I think. Yes, VLAN 10 was created previously. 10, 20 and 30 to this switch. So let's see if we get that or not. We have to check the configuration revision number. Show VTP status. The configuration revision number is 0 because it's a transparent switch. As we have learned that the configuration revision number for transparent switch is 0, so this remains 0. Now let's move over to this switch. We have to set it as the client mode. In the client mode, VTP mode client. Okay, CLIENT, yes. VTP domain is CCNA, and VTP password is Cisco. Done. Let's see VTP status. Okay, show VTP status. Configuration revision number is 3. Now let's see show VLAN brief. See, whatever we had created in the server switch has been transferred or has been copied or transferred to the switch in the client mode. Now let me just revise. This is the server mode. It creates and deletes VLAN. We have created, yes. It has advertised the VLANs, yes. Now let's see client mode. It can install VLANs from other advertisements. So as this switch is in server mode, and it did advertise it. It did advertise the VTP, the VLANs. Just because it's this switch is in client mode, this did install all the 3 VLANs that was created, and this switch didn't. This switch didn't because it's in transparent mode, and we know that in transparent mode it does not install VLANs from other advertisements. Now if we go to the transparent switch, and if we create those very VLANs, we will get it, because you can create those VLANs. We can create any VLANs locally. So we can create here, configure, okay, VLAN 10, 20, 30. Okay, wait. So let's say 10 to 30. Oops. 10, 20 and 30. So let's do it one by one. Naming is not important, so we'll just show VLAN brief. See, 10, 20 and 30 is also there, but we created it locally. So I hope this thing is clear. This how it is happening in the practical world, how it's happening in when you are configuring it, and when you are adding another VLAN. It gets automatically transferred to the client switch, but not to the transparent switch. So this was all about VTP, and now let's see what happens when this PC tries to communicate with this PC. This PC over here on the, so let's name it as A, and it's trying to communicate to B. This, let's see what happens. Okay, so I have to configure and say IP address 192.168.10.2. Default gateway don't need it right now, but still it's a good habit. 10.1. This is 10.1. This is 20 network. 192.168.20.2 and 192.168.20.1. This one is a 30 network. 192.168.30.2 and this is 30.1. Okay, so before doing that I should, I think, yep, no, so let's ping from this computer. Ping 192.168.30.2. let's see what happens. This is 30.2, right? This is 30.2, right? This is 30.2. So let's see if we get a ping or not. We are not supposed to get the ping. We're not supposed to get the ping reply. Why? I will tell you in a minute. Okay, let's go over here. Okay, I need to copy this image. I need to paste it here. Okay, so this is in server mode, this is in transparent mode, and this is in client mode. So whenever a PC from this section tries to communicate with this section, what really happens is the packet gets dropped over here. The transparent switch, the data doesn't travel from this switch to this switch. This is because whatever VLANs we have got over here, the trunk port carries the data along with the VLAN ID tag. Data plus VLAN. So if this is in 10, this is VLAN 10. What happens over here is it will generate data plus VLAN 10. It goes over here. It sees there is no VLAN 10 configured. Okay, just forget that I created the VLAN 10 over here because I did it manually. I did it locally. So we should not take that into account. Just just erase that memory. Okay, so it sees that there is no VLAN 10 over here. So what it will do is it will drop the packet and the data does not travel to that section. So this is one of the most vital area of VTP and VTP configuration revision number and the transparent mode of the switch. Okay, so this was about the communication between a server switch communication from a user under the server mode switch to a communication to another user under the client switch, and in between there is a transparent switch. Okay, so let's see another scenario like this. Suppose we have a scenario like, I need to delete this. Okay, new. Yes. Let's see, we have three switches over here. Switch 1, I'm going to draw a box like this, okay. Switch 2 and switch 3. Let's see, multiple users, okay. Now in some ways or the other, this switch 2 gets damaged. Before this being damaged, there was a good flow of communication, good flow of data, okay. So it was a good network. So suppose in some ways or the other switch 2 gets damaged. What is the immediate solution? The immediate solution is to check whether you have a new switch or a spare switch. Let's take the worst case scenario that you don't have a new switch but you have a spare switch, okay. The only solution is to replace this switch with the spare switch. So let's erase the number 2 here and say this is switch number 4, which was this switch, and as it was a spare switch, so it should definitely have some configuration revision number, okay. Suppose the ongoing configuration revision number is 100, okay, 100, and this spare switch when it was last configured had configuration revision number 300, 200 more than the ongoing revision number. So as we saw that highest number wins, alright, so we saw that highest number wins, highest number wins. So what it will do is that it would obviously advertise the updates, and we will see that there is a problem. The problem we might face is that the old switch was used earlier and it might have a configuration revision number higher than the ongoing configuration revision number, which is 100, and the spare switch has 300. So now the whole network will go down in a minute because this will advertise it as the revision number is not matching, the domain remains unsynchronized, and the database will be corrupted. The entire VLAN database will get corrupted because there is a mismatch in the revision number. So what to do in case of these types of scenarios? The immediate solution is that we should replace this switch. When we are replacing this switch, we should always configure it in the transparent mode, okay, transparent mode. The reason is that the configuration revision number, it's fine if it is low, okay, it's fine if it is lower than the ongoing configuration revision number. It's even better if it's 0, okay, it's even better that it's 0. So when we are installing it, okay, when we are installing the spare switch, we should always configure it to the transparent mode, let it run with the transparent mode for a few minutes and then revert it back to whatever mode you were previously using the switch before it was replaced, okay. Suppose the switch number 2 that it was, okay, first when we took it happened to be in client mode. So after a few minutes of keeping it in transparent mode, reconfigure it back to the client mode. So in that way the database will not be get corrupted, and the configuration revision number will be in sync, and the domain will also be synchronized. That was the first solution. The second solution is to change the VTP domain name. If you change the VTP domain name, then there would automatically, the VTP updates will not get installed. So when it is advertising it, it's in a different domain. It will not we will not it will not reflect the changes over here. This will stay the same, this will stay the same, and this will also stay the same. So this was about VTP and VLAN combined, and the next session will start with ether channel, and its lab. It will take only one lecture, one video only to complete ether channel, and then we will start with STP. So STP and RSTP will be the last topic of switching, and after that we will see what is routing.